You've got a patio stone that is 24 by 36. So if I draw one of them, 24 here and 36 here, does that make a square? No, it's a rectangle. So obviously, I can't make a square. If you wanted to make it closer to a square, could you see that you could add another tile down here? But now it would be too long on that side. So we would need to add another one here. And we have 4 tiles already. But now it's too long on this side. So now I need to add another one down here. And if I had drawn it to scale to begin with, that would be a perfect square. Because 24 plus 24 plus 24 is 72. And 36 plus 36 is 72. Now again, this didn't take too long drawing it out to figure out how, what is the side length of the smallest square patio. And since we're dealing in inches, wouldn't be a very big patio, would be 72 inches. What kind of question is this in case we started doing this and realized we'd be drawing a lot of patio stones for a long time before figuring it out? Is this a greatest common factor question? Is this a prime factorization question? Is this a least common multiple question? Can you see that drawing it out was like leapfrogging? I drew one, and I noticed this side was too short. So if I needed a square, I need to add another one here. But then the other side was too short, so I needed to add another one there. And that was like our method of leapfrogging. Where we found the lowest common multiple of 72. If you recognize that you're leapfrogging, then you might want to go to the prime factorization if it was a question where I'm just drawing way too many tiles and it's taking way too long to draw it out by hand and count it slowly. Okay? In this case, the leapfrog method was actually not bad at all, really quite quick. Didn't take us long to get there. But what you need to be able to do is sit back on a question like this and say, can I recognize that this is a least common multiple question? And then use that and go from there. The other type of patio question that sometimes comes up is the opposite of this, where they tell you how big, and we're going to add it as an example here. They tell you how big the patio is. So let's say we've got a patio that is 250 inches one way and by 75 inches the other way. So you've got 250 by 75 inches. (250 inches here and 75 inches there. What is the largest square tile that can be used to fill the patio if tiles cannot be cut. Now it's important that it says if tiles cannot be cut, because if tiles could be cut, you could buy one huge tile that was 250 by 250 and just cut it off, and you would have only one tile to do the whole thing, and it would be perfect. Of course, those are big tiles and would be expensive to buy, and you'd probably break it trying to put it in your trunk or something like that, or driving it home. Now, you could buy 1-by-1 tiles. Could you see that 1-by-1 tiles would fill this whole thing up, and that would be great? Because one divides both 75 and 250, but those wouldn't be the biggest ones, right? We can't buy 2-by-2 tiles, because 2-by-2 tiles would fit along the 250, but 75 isn't an even number. Could we buy 3-by-3 tiles? If you broke 250, can you divide that by 3? Because you can divide 75 by 3. So you could buy 3-by-3 tiles if you went this way, but going along this way, 250 doesn't divide by 3. So you need to find a number that divides both of them, bigger than 1. Can you see a number that would divide both 250 and 75? 5. So 5 works because you could, 250, you'd need 50 of them along this way. And you would need, divide by 5, 15 along that way. But the question is that the largest square? And what are we doing when we're trying to find a number that divides both 75 and 250? What's that called? Factorization. And factorization is going to help us find the greatest common factor. So this is a question that's looking for the greatest common factor. And if we use factorization, here's 75. It divides by 3, gives us 25, divides by 5, gives us 5, divided by 5, 1. And 250 divides by 2, 125. Doesn't divide by 3, divides by 5, 25, divides by 5, 5 divides by 5, 1. And for greatest common factor, we have 75 equals 3 times 5 times 5. And 250 equals 2 times 5 times 5 times 5. What do they have in common? They both have a 5, and they both have another 5. So the greatest common factor here is 25. And you would need 3 of them to go along there. And you would need 10 of them. Oh, my scale was wonderful again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, my scale was way off. So you could have 3 by 10, and then you could have 25 inch by 25 inch. So what is the greatest, largest square tile that can be used? It would be a 25 inch by 25 inch square tile. That would be the largest one. That is still a pretty massive tile. If you imagine what 25 inches, that's like about that big. Those would still be really, really expensive. I've got 2 more questions for you to practice, just with greatest common factor. Here we have 2 numbers to practice, and a lowest common multiple one with 3 numbers, and then I'll hand back, we'll start with this one. I'll hand back your projects.